So what I did is I keyed it up, and then I decided what I thought you might have the most difficulty with at this point. So what we're going to work on more than anything else is graphing. And that's what we're going to focus on today. So far, the different kinds of things that we have graphed, and these are not necessarily in any order. We just recently finished graphing rational functions. Rational functions, the rational f of x. We did polynomial functions. Those were nice, smooth, continuous curves. We did quadratic functions. And if you remember, those guys are our parabolas. We can give them a name. We also did piecewise functions. Now I'm going back into chapter 3. And then all the way back in chapter 2, we did circles. Now I'd like to point out that this is the only thing that we have graphed that is not a function. A circle would not pass that vertical line test. So those are the 5 things that we've learned or worked on in terms of graphing for our course. So on your review to date this week, you actually have one of each of these. So I'm going to come in and let's do one of each of these. And the directions are pretty generic. Your directions on the review simply state, graph each equation or function. Do not use your graphing utility. Show all work necessary to complete your graph. In other words, you need to know what's important. So the intercepts, the asymptotes, the vertex, etc. So I'm not going to lead you through it. You have to recognize the equation and then tell me what we need to graph it. So again, these are not in any order. Let's go do some graphing. So our directions are just going to say graph. And our first one's going to be f of x is equal to negative 3x squared plus 3x minus 2. So negative 3x squared plus 3x minus 2. So my question is, what is that the graph of? When I'm done with that, what kind of shape am I going to have? Does anybody recognize it? Nobody?
U.
I'm sorry?
A U-shaped?
Yep, it's going to be a U shape, so it'll be a parabola, and that's because it's a quadratic. So we're going to recognize that it's a quadratic. That means the largest exponent we see is a 2. That tells me that it's that U shape. Beautiful. Is this particular U going to open up or will it open down?
Down.
Down. And that's because of the negative out in front. So we know it's going to open down. So I guess it would look more like that. So in order to graph it, what do we need?
The X, Y intercepts?
Yep, so we need the intercepts. And what else do we need? There's one more thing we need. Would it be helpful if we had that top point? Does anybody remember what we called that?
Maximum?
How about vertex? So the vertex, so yes, it is the maximum, but to plot it, we need it as the vertex. Okay, so that's what we need, and that's all you need. You need the vertex and you need those intercepts. So let's go find them. I'm going to do the vertex first. And if you remember, we had a formula. We did negative b over 2a. So for us, that's a negative 3 all over 2 times a negative 3. So the negatives will cancel out. The 3's actually cancel out, and I end up with 1/2. So not a very nice number, but we can do that. To find the y-coordinate, we're going to plug that 1/2 back into the function. So I have negative 3 times 1/2 squared plus 3 times 1/2 minus 2. And I would just use the graphing, I would just use the calculator to figure it out. You can't graph using a calculator, but you can definitely use the calculator in order to find stuff. 2 minus 2. And so that gives me on my calculator a negative 1.25. But because we're expressing it in terms of fractions and not using decimals, I'll just have the calculator turn it all, although you may recognize it. It's a negative 5/4. So our vertex that we need, I kind of need room because I'm going to start erasing over here. So our vertex is at the point 1/2, -5/4. Beautiful. Okay. Then we also need the intercepts. How am I going to find the y-intercept? Because it's the easier one to look for. How do we find that y-intercept anytime?
Place the x with 0.
Yep. So if you replace all those x's with zeros, what are you going to get?
-2.
Yep. Okay. And because I want you to think about this logically, before I go look for the x-intercepts, I'm going to graph what we've got. Okay. So we have 1/2 and -5/4. So 1/2 is about there. -5/4 is about here. We know the y-intercept is down here at -2. Is this graph, if it's opening down, going to have any x-intercepts?
No.
Nope. So I'm not going to waste the time to go find them. I already know that it's opening down. So because this was at 1/2, I know that I'm going to have another point over here that's symmetrical. So if I'm at 1/2, one's over here at 0, the other one's at 1. And then I can draw it in. I need more than 2 points to be able to draw a nice shape. So there it is. Now, if you did not go graph it first and then came to look for the x-intercepts, what would happen is that you would get a negative under the radical, which is telling you that you're ending up with complex roots. And we know we can't graph complex roots on the xy plane. So I think it's worth finding the vertex and the y-intercept, plotting that or taking a look at that, the opening up or down, and then go find the x-intercepts if you have them. And that's your quadratic. So it does have a maximum. The maximum value is that -5/4. So if you had to find the domain and range, what would be your domain?
-infinity and infinity.
Nice. -infinity to infinity. What would be our range? Where's the bottom of my picture?
-2 and -infinity.
So the other way around, but yes.
Ah, dang it.
So, but again, this is why you're sending me your scratch work on exam, so that when you do that kind of thing, I can give you full credit for it, because I know it's just a sloppy mistake. So good job. There's our quadratic. Any comments or questions about the parabolas?
No.
Yay. So you'll have one of those on your review to date. How about f of x is equal to a -2x plus 3 if x is less than 0. It's going to be equal to the square root of x if x is greater than or equal to 0. So this one's the easy one to classify. It's the piecewise function because we can see the two pieces to it. So our particular piecewise function has a boundary at 0. What can you tell me about each of the pieces? We know that this is the left side. And what kind of shape is it going to be? So what kind of shape is y equal -2x plus 3? Boy, Rich, I don't know what happened to that, but I didn't understand that. I'm going to assume you told me it was a line. So it's a line, in which case we only need 2 points and we're good to go. What about the right side? So the piece that's going to go on the right. What can we say about it? I'm sorry? So it's that half a parabola shape? Good job. Thank you. Yeah, let's go do some left and right side analysis in terms of points. So on that left side, we're doing y equal -2x plus 3. The very first number I'm going to plug in is my boundary number, which is 0. And then I need a number that is to the left of that, so I'm going to go ahead and use -1. So again, it's important to remember that you're going to start at the boundary number and go to the left. In terms of the 0, is it an open or closed circle?
Open.
Good. And that's the equality telling us that. So, okay, if we plug in 0, we get a 3. Let's plug in the -1. So that's -2 times -1 plus 3. So it's a +2 plus 3, and I'm going to get a 5. Okay, and that's all I need. That's enough. And I like to, again, plot it as I'm doing it. So I'm going to go plot that. So the point 0, 3, make sure it's an open circle. And then I have the point -1 and -5. And you only have one open circle on a piece. So we're going to start at the open circle and go to the left because it's the left piece. So there's our line that's existing on the left side of our picture. So the right side is y equal the square root of x. You don't necessarily need to plot points if you know what it looks like, but we'll go ahead and plot points just to make a prettier picture. So I'm going to plug the boundary number in again. Again, this is where stuff changes, right? So this time, is the 0 going to be open or closed?
Closed.
Good. Fantastic. Square root of 0 is 0. If I plug in 1, and again, I'm picking numbers that are to the right, square root of 1 is 1, and then I'm going to plug in 4. Square root of 4 is 2, and that gives me a pretty good shape. So I've got 0, 0. At 1, I'm at 1, but at 4, I'm out at 2. So I'll get that half parabola shape that I need. And there's your piecewise function. Okay, what if I asked you for the domain of that? This is the harder part, right? So in terms of left to right, are we using every possible x value?
No.
Aren't we? Because the only one that would be in question would be 0. It's not part of this piece, but it's definitely part of this piece. So every single x value is getting used. And you can kind of look at it back up here and say, well, you're picking to the left of 0. This is adding in 0 and going to the right. So its domain is -infinity to infinity. What about the range, though? So from bottom to top, where does our graph start? Where's the bottom of our graph? 0. Good. We'll put a bracket there. And can I go off towards infinity? So again, the question would be that open circle. But this guy's going to keep getting bigger as it goes out. So eventually, whatever value of 3 is here, in fact, if you plug in a 9, you'll get a value of 3. You'll cover that y value at some point on that picture. So the domain is all real numbers, but the range starts at 0 and goes towards infinity. So again, that's our piecewise functions. Okay, let's graph f of x is equal to 4x minus 3 over x plus 2. So 4x minus 3 all over x plus 2. Okay, when I look at that, I don't freak out. What I'm going to recognize is that because x is in the denominator, it's a rational function. And for rational functions, we need the intercepts, but we also need all the asymptotes. So we need the vertical asymptote. We also need the horizontal asymptote. And that's because it's a rational function. So again, recognizing what it is and then recognizing what you need to graph it is so crucial moving forward. So, okay, let's go by the intercepts first because they're the easiest thing. So do you remember from earlier in the week how we find the x-intercept? Anybody?
Is it the denominator?
Numerator. Yeah. Again, you would set the whole function to 0 because that's how we find x-intercepts, right? You let y equal 0. but you'd get rid of the denominator by clearing the fraction. So then you're going to set the numerator to 0. So the next would be equal to 3/4. So our x-intercept is 3/4, 0. Okay, y-intercept, we know to replace all those x's with zeros. So if all the x's are zeros, what's our y-intercept?
-3.
Over 2? So
Yeah.
-3/2. Next, we'll do our vertical asymptote. Again, you can do these in any order. The order does not matter here. It's just we're used to doing the intercept, so that's why I always pick and do those first. Now, the vertical asymptote is the one that's coming from the denominator. This is where the graph cannot exist. So you're going to set the denominator equal to 0 and solve. So we'll get x equal to -2. Now, that is a line. It's going to be a vertical line at -2. Okay, the horizontal asymptote is the one that's got pure memorization behind it. You compare the degrees of the numerator and denominator, and what do we notice about our degrees this time? So the degree of the top is 1. What's the degree of the bottom? So the degree is that exponent. So aren't they both 1s? So my degrees are equal? Okay. So then you go to the ratio of the coefficients. So for us, the leading coefficient in the numerator is a 4. The leading coefficient in the denominator is a 1. So you're going to get y equal to 4. And that's your horizontal asymptote. So. Okay, comments or questions? So that's all of the analysis. Now we're down to graphing it. So we have a point at 3/4. And I have a point at a -3/2. We have a vertical asymptote at -2. And I think I was using blue the other day, so I'm trying to be consistent. So that's our x equal -2. And then our horizontal asymptote, which describes the end behavior, is actually way up there at 4. So it's pretty high. Okay, and that's all we got. So we have 2 points and 2 dotted lines. So again, go to where you know what is happening. So we know that in this area, we have to go through those 2 intercepts. And because of all our multiplicities are odd, we know it's crossing or in opposite regions. So we're going to start by the blue line on the bottom. We're going to head through that y-intercept, then that x-intercept, and then head off towards the red line because we have to start by an asymptote and we have to end by an asymptote. So it's going to look something like that. Okay, on the left side, because there is no point over here on the x-axis, and because we're below over here, we know we need to be above over here. So it's going to come in and do something like this. So there's our bow tie that we're expecting because of those opposite multiplicities. So every time we cross a vertical asymptote, they should be on opposite sides of it, above and below kind of thing. So there it is. Any comments or questions about that one?
No.
Kind of nice. It was a pretty graph. Okay, that's your rational function. 2 more to go. We're on a roll. Okay, let's come in and graph x squared plus y squared plus 4x minus 2y minus 20 is equal to 0. What is it? Do you recognize it?
Circle.
Yep. It's the only one that's not in function notation. You'll notice that. So this is definitely a circle. It's not a function. It will fail the vertical line test. We also recognize it because it's the only one that has a y-squared in our class. It's the only thing we graph that has y-squared. So to graph a circle, what do we need?
Standard form.
Yep, we need to get into standard form so we can find the center and the radius. And that is why we need standard form. Beautiful. And because this was one of the oldest things we've graphed, just a reminder that standard form is x minus h squared plus y minus k squared equals r squared. So we're going to complete the square. And to do that, we are going to group like terms. So I'm going to put the x's together. I'm going to put the y terms together. And I'll move the 20 to the other side. So I have x squared plus 4x plus y squared minus 2y equals 20. So to complete the square, you come in and you take half of the first degree terms. So for the x's, we've got x squared plus 4x. Well, half of 4 is 2, and 2 squared is 4. We'll do the same thing for the y's. So half of 2 is 1. 1 squared is 1, which equals 20 plus the 4 plus the 1. So whatever I added here, that 4 and that 1, I'm adding over here also so that I'm not changing the equation. So you can do whatever you want to an equation as long as you do it to both sides. Okay, then we're going to come in and factor. What does x squared plus 4x plus 4 factor into? So you need factors of 4 that add to 4.
2 and 2.
2 and 2, and they'll both be pluses. They're both pluses because we're adding to get to 4, and the first sign's a plus. And we'll do the same thing for the y's. We're going to have a y and a y. On the other side, when I add, I'll get 25, which is perfect because it's a square. Okay, what are factors of 1 that add to 1? I'm sorry, factors of 1 that add to 2.
1 and 1.
1 and 1. What kind of signs are on those guys? Positives or negatives?
Negatives.
Yep. And that's because the first sign is a negative. So now in standard form, we have x plus 2 squared plus y minus 1 squared equals our 25. So it looks really good. Okay, so where is my center then?
2, negative 1.
Fantastic. Whoops, let's flip those around. So negative 2,
Negative
positive
2.
1. Yeah. Remember, when you pull them out of the parentheses, you always switch the signs. And r is going to be the square root of that constant, which is 5. Okay, that's all I needed. That's a pretty big circle. I don't think I'm going to get it on my board. We're at negative 2, positive 1. So we're right there. And then we'll go out 5, 1, 2, 3, 5, 2, 3, 4, 5, 1, 2, 3, 5. So it looks something like that. So not a function. It actually belongs to a classification called conics. And if we had more time, we would do the conics, but you'll pick them up in a pre-calc class without the pre-calculus algebra. So, okay. Everybody good with our circle? We got one more. Okay, so the other thing that we've graphed in our class so far looks like this. So f of x is equal to, oops, negative 3 times x plus 2 squared times x minus 4 times x plus 1 cubed. That's a 3 on the end of that. Nope, sorry, that's a 2 on the end of that. I can't read my own writing. That's a 2 also. So, okay, so negative 3 times the quantity x plus 2 squared times the quantity x minus 4 times an x plus 1 also squared. It's a polynomial. So we expect a nice, smooth, continuous curve. In order to graph it, We need those x-intercepts and their multiplicities. Why do I need their multiplicities? What is that going to tell me?
End behavior.
Yeah, it's going to tell us not the end behavior, but whether it's bouncing or crossing. So those outside exponents are going to tell me whether I'm going to cross at those x-intercepts or bounce at those x-intercepts. We also need the y-intercept, and we need the end behavior, because I have to know where I'm going to start and where I'm going to stop my picture. Okay, so the intercepts and their multiplicities, the y-intercept, and then the end behavior, and that's what we're going to need. Okay, so let's break it down. Help me out. What are my x-intercepts? And because I'm asking for them as intercepts, I'm going to write them as points. Okay, what's the first one going to be? Does this -3 out in front impact those intercepts? Does it have an x attached? So no, yeah, because there's no x to it, I don't need to use it at all. So we'll pick up the x plus 2 as a factor. That's going to give me a -2. What's its multiplicity?
2.
Great. What does that tell me about the graph? Is it going to cross or is it going to touch?
Touch.
Okay, the next x-intercept is at
4.
you. Its multiplicity is
1.
so the graph is going to
Cross.
fantastic. And the last x-intercept
-1.
and its multiplicity.
2 for a touch.
Yep, fantastic. Yay. Okay, y-intercept. This is the ugly one. Especially when I make one up, and these are very easy to make up, so they usually get pretty bizarre y-intercepts. So I have the -3 out in front. All the x's are 0, so I'm going to have a 2 that gets squared. I'm going to have a -4, and I'm going to have a 1 that's going to get squared. Okay, well, that's a -3 times a 4 times a -4 times a 1. So I did all the exponents first. The negative times the negative is going to make it a positive, and now I'm down to multiplying. 3 times 4 is 12. 12 times 4 is 48. So my y-intercept is way down there at 48. And that's, or I'm sorry, way up there at 48. That's why they get a little ridiculous, because you get y-intercepts that are, I think, a little extreme. What about end behavior? So how am I going to figure out my end behavior? Well, I need the power function, correct? So if you were to multiply all this out, you would have an x to what power? So 2 plus 1 plus 2. So a -3x to the 5th. So the x to the 5th is telling me it's odd, but I have a negative leading coefficient. So normally our cubics start below and end above, but because that negative is reflecting it, we're going to start above and end below. And that's everything I need. Okay, got to come back and find everything. So I have -2. I have +4. I have a -1. And I have a +48. So -2, +4, -1. Yep. So we know we're going to come in from the left side. We're going to come in towards that -2. And at -2, we said we were going to touch. So it's going to stay on the same side. I'm going to head up and hit the -1. At the -1, it's touching again. So it's going to bounce up. It's going to go through that x or the y-intercept. And then head over to the next x-intercept at 4. And at 4, it has to cross. So it's going to head on down. So it does something like that. My guess is it does more like this, because that would be a little bit smoother. So clean mine up a little bit. So it looks something like that. And sure enough, it ends where we said it was going to end. So I think the polynomial functions are some of the easiest things that we graph, because you can just pull information off. You don't have to do a lot of work to it, like the parabola. So. Okay, and those are the 5 things that we've graphed so far. We still have to add in the exponential and log graphs, which we'll do in chapter 6 moving forward from here. So the only other thing that I wanted to talk about off your review that I think may be a little rusty is the domains of the functions. So So I'm specifically referring to, this would be question 3 on your review. So let's just come in without graphing. I need to find the domain. Of each function. And in no particular order, our first one is h of x equals the square root of 2x plus 3. So I need to find its domain. So in other words, what numbers can I plug in for x and end up with a real number that I could graph if I were graphing? So does anybody remember what we do? This goes way back into chapter 3, like 3-4 weeks ago now, or longer. Anybody remember with a radical what you do?
Set it, an inequality to 0. It's greater than 0.
Beautiful. So we're going to take that inside stuff. We're going to set it greater than or equal to 0 because it's okay to have 0 inside the radical. That's exactly it. Good job. So, and we kind of alluded to this yesterday. You'll see this in section 5.4 also. So a good review for that. Okay, let's go ahead and solve that. We'll move our 3. 2x is greater than or equal to negative 3. And then we'll divide by 2. So x is greater than or equal to a negative 3 halves. So what we're saying is that on a number line, if here's negative 3 halves, we're going to have a closed circle, and we're going to go to the right. So it looks something like that. But again, because it's a domain, we're going to write it in terms of interval notation. So the bracket for the closed circle, we're going to start at negative 3 halves and go off towards infinity. So anytime you have an an even root, then that's your domain. Comments or questions about that? Okay, same directions, different type of function. So let's say we have g of x is equal to x squared over x squared plus 2x minus 24, just to be different. So x squared plus 2x minus 24. Okay, now we know after the work this week that this is called a rational function because x is in the denominator. How do I find its domain? Anybody remember?
You factor your denominator?
Okay, so that denominator is going to factor into what? X plus 6?
4 and 3? Or,
Well, we need factors
yeah,
of
24. I was
24
thinking 12, yeah.
that are going to say, oh, yeah, yeah. No, I went with a bigger number just to be different because I keep picking smaller ones. So, yeah, factors of 24 that subtract to 2. Oops, sorry, that was the dog. Are 6 and negative 4. So the 6 gets the positive because of the plus 2. So, okay, so what numbers can we not use? So we can not use in this function a negative 6 and a positive 4. That's where the vertical asymptotes would be if we were graphing it. Okay, so what we're saying is that on the number line, here's negative 6, here's positive 4, there's open circles or dotted lines on the graph there. So what's our domain then? Negative infinity to negative 6.
Yeah.
Yep, you can use all of that. And then we'll go from
Negative 6 to 4.
nice. And then from
4 to infinity.
yep, that's exactly it. And those are the ugly domains that we have to do. So good. Those are the rational functions. And again, it's what numbers you cannot use in the denominator, the numbers you have to exclude from the domain. So nice. Okay. There's one more on problem 3. And that is something like, what if I gave you f of x is equal to x squared minus 4x. And I want to know its domain. So same question still. Let's find the domain. X squared minus 4x. Does anybody know what the domain is? So does it have a radical? Nope.
It's all real numbers, right?
Yeah, that's exactly it. So negative infinity to infinity. So it has no radical. It has no x in the denominator. So that means that the domain is automatically all real numbers, negative infinity to infinity. Correct. So the only restrictions you have to worry about when we talk about domains currently are radicals and x in the denominator. So. Okay, and those are the only ones that when I looked at it, I thought would cause the most issue or the most trouble. Did anybody get a chance to look at it, and do you have any other questions about it that you want me to address?
When I was trying to look at it, it was saying fail, and I had to keep reloading it.
Yeah,
Uh-oh.
same.
Uh-oh. Is it a PDF or is it a Word doc?
It said
says
it couldn't
I
load the
can't convert
PDF.
into a PDF.
Well, that's a little strange. Okay, why don't I email it to everybody? Okay, that way I know you've got it through an email. And if that doesn't work, somebody needs to respond and let me know that it's not working so I can get it to you. I don't know how else. I could try and email. I'm going to try and email it through Blackboard first because that's where everybody's listed. If that doesn't work, then I'll try it through Pearson. I was able to get into Pearson early this morning. At some point, they're supposed to be down for maintenance, but then they said it's intermittent. So you may be able to get onto Pearson today or not. So, okay, I will definitely try and send it as a PDF then by email, and I'll go do that right now. So anybody able to look at it and actually have a question?
No.
Okay. Any other comments or questions?
Nope, I'm good.
Okay.
Okay, we're good to go. So next week we'll lecture on Monday, Tuesday. I only have 2 sections, and then we have an exam next week. So we may spend a couple of days reviewing for that. We'll see how you guys are feeling. So, but we'll worry about that next week. So have a great 4th of July. Stay safe and stay healthy. Avoid those mass gatherings, whatever you do. Okay.
All right, you too. Thank you.
Okay. Bye-bye.
Bye.